Hello everyone, welcome to the another very important session. So guys, today we are going to discuss some more important questions and the concepts in our session today. So I hope that the discussion which we will be doing today in the session will be getting clear to all of you. But in case if you will be having any doubt anywhere, you can surely let me know about it and we will try to consider those points then. So here are a few slides I'm quickly going to show you all and then we will go over the other important slides too. It's here, the first one, like the steps you can see that how you can get the 7-day free trial on Unacademy app. Okay, that if you want to start your preparation under the guidance of top educators, so what are the steps you have to follow and how you can start your preparation under the guidance of top educators. So 7-day free trial, step number 1, it has been shown here. You can open your Unacademy learning app and you can just enter your phone number, then verify your phone number with the OTP, then choose your target exam like CSIR UGC net, enter your activation code, it can be like Unacademy, and then you are gonna have like the next thing, that is download the app to start your preparation. Okay, so that's what you can do, guys. Now I'm gonna like show you the other slide and we will be okay guys, let's continue the discussion. I'm even going to show you the other slide having all the benefits mentioned here on this regarding the Unacademy Plus Iconic and the Lite subscription. So you can have a look at all the benefits you will be getting if you will take the Unacademy Plus, Iconic or the Lite subscription. Also guys, you can use and apply the code. Give me a second guys. Yeah, use and apply the code Anjali A Live to get the discount in the total subscription amount. I'm just gonna continue the discussion, guys. So today we will be talking about the classical mechanics most important questions and the concepts. So if in case you will be having any doubt anywhere, you can surely let me know about it. But if everything will be getting clear to you, you can tell me that too and we will be continuing the discussion that way. Okay. Also, guys, few more slides I would like to show you. The first one is regarding the Unacademy Learning app. The second one is regarding the session, and this is something about me. This is going to be regarding the community feature we are having on Unacademy Learning app, which will be helping you to stay updated to know about the latest information and latest updates. So guys, this is something which is going to be more helpful for everyone to know about, as all these details and the things can be helping you to take your preparation to another level. Now we are ready to start our discussion on classical mechanics. There are important topics, questions, concepts what we will be considering in the session today. So let me just give you the first question right now, and as you will keep on getting the answer of these questions, we'll go ahead for the next one. Or if anybody will have any doubt in any of the questions I'll be discussing, you can surely let me know about it. I will be explaining those points and then we will go to the next one. Okay, so the first question is, a particle is moving under the action of a generalized potential VQ dot, which is equal to 1 plus Q dot over Q square The magnitude of the generalized force is. Options are 2, 1 plus q dot over q square. Option B is 2, 1 minus q dot over q square. Option C is 2 over q cube. Q dot over q cube. Start working on it now, guys, and let me know whatever you think is the correct answer according to you. And if you will not be getting it, I'll be helping you then. So after some time, I'm just going to continue the discussion and I'll be talking about all those points. Okay, guys, for them, those who don't know how to proceed further, what steps you have to take, let me just tell you. A particle is moving under the action of a generalized potential, which is V as a function of Q and Q dot, which is equal to 1 plus Q dot over Q square. The magnitude of the generalized force is, right? So in this case, what we have to do, it's going to be, you all know, F is equal to what? It is related to V as well, right? So force, or you can say the potential, right? These are related ones. So right now you want to find generalized force, and you also know that your Lagrangian has the kinetic and potential energies associated with that. Okay, so how the force and the energies are related? In general, they have a specific relation. But when we talk about the generalized potential, we talk about the generalized force. So one thing you need to know, you had the equation of motion, okay, Lagrange's equation of motion. In that equation of motion, just simply consider the L replaced with V, and that gives you the generalized force. So what I want to say, I'm just going to write it here. d by dt delta, okay, V over delta Q dot. In general, what you write delta L over delta Q dot minus delta L over delta Q. So delta V over delta Q. And that is equal to what? 0. So that's what you have to consider. If in case you are still having any doubt, just let me know. Oh, but just because I have taken the V here, I don't have to equate it with 0. I'll write the generalized force, which is FQ, and that's the expression we are going to have. This is how we can simply find it. So just plug in the value of V in the expression, differentiate, simplify, and get the value of generalized force. If in case there is anybody having any doubt, we can talk about it. But if it is clear, that's great. So after this, I'm going to take the next question. So right now, guys, I can't see your comments. And we are going to take the next question. But what I'll do, I'll keep on explaining the questions I'll give you, so that anywhere, if anybody will have any kind of doubt, they can understand it. They can get this part, that how they're going to solve that. And these are mainly the topics from where you can expect the questions to be there in your upcoming exams. This is cos beta p, this is sin beta p, okay? Is canonical for options are done. Okay, try it now and let me know as you will get it done. If in case you will have any doubt anywhere, I'm gonna quickly explain it just after some time, and that's how we'll be discussing. And I'm even gonna give you the next question after this, guys. So keep trying, and let me know as you will get it done. Let P and Q, that's a small p and a small q, and capital P and capital Q be two pairs of canonical variables. The transformation, which is capital Q is equal to q to the power alpha cos beta p, and capital P, which is equal to q to the power alpha sin beta p, is canonical for what? That's what they're asking you to find. Okay, now I'm gonna start the discussion too. So if anybody has already got the answer, they can check it like whether they are getting it correct or not. And those who are not able to get it, for them, I'm gonna do the discussion now. So actually, guys, in this case, when you have the capital Q and capital P given to you, you just simply have to consider the Poisson bracket of capital Q with capital P must be equal to 1. Now, when I'm saying Poisson bracket, it must be delta Q over delta Q, delta P over delta P, minus delta Q over delta P, and delta P over delta Q. This must be equal to 1. Now you can see you already have the Q and P given to you. So what you have to do, you just have to differentiate them as per whether you want to differentiate it with respect to small q, small p, capital Q, capital P. So first one, we want to differentiate it with respect to small q. So that is alpha q alpha minus 1. Cos beta p delta p over delta p, that's going to be beta as it is, you will have there, as well as sign will become cos, so cos beta p, q to the power alpha beta cos beta p. So beta I'm going to write here, q to the power alpha also I'll write here, and then cos beta p means cos square beta p, right? Then minus delta q over delta p, so it's going to be beta q to the power alpha sin beta p with the negative sign, so that will become positive, beta q to the power alpha sin beta p. Delta p over delta q will be what? That's going to be your alpha q alpha minus 1 sin beta p. So sin square beta p, alpha q alpha minus 1, that is equal to 1. It's going to be alpha beta q to the power 2 alpha minus 1. Okay, alpha beta q to the power 2 alpha minus 1 cos square beta p plus sin square beta p, that's going to be 1. Now you got this. Now you can also write this one I have noted down here as q to the power 0, right? So now when you will compare the powers, you will have 2 alpha minus 1, which is on the other side, that's the power, that is equal to 0, which will give you alpha is equal to 1 over 2. Okay, now when you got the alpha is equal to 1 over 2, now you have to decide what should be the value of beta. So beta must be 2, so that after multiplying and after simplifying, you will get the value here as 1. So this is what you have to consider. Let me know if in case there is anybody still having any doubt, we can consider it then. But if it is clear, that's great. Okay, after this, I'm gonna take the next question now, and I hope every step we have talked about will be clear. The rod is rotating. Rotating about the vertical axis with a constant angular speed omega. At any instant, r is the distance of the bead from the origin the momentum conjugate to r is. Options are mr dot 1 over root 2 mr dot 1 over 2 mr dot and root 2 mr dot. And here the figure which is shown, z cap, x cap, it should be symmetrical on both sides. It's 45 degrees here, it's m here, it's r here, it's omega, and that's it. Now you have to solve it like to get the momentum conjugate to r. I'll be waiting for your reply for some time, and then like once everybody will get it done, I'm gonna even start the discussion about solving this question, that what are the steps you have to take, how you can proceed further, what you can do, and that's how like we will be working on this part. Waiting for your reply, guys, and then I will be starting the further discussion as well. So a bead of mass m can slide without friction along a massless rod kept at 45 degrees with a vertical as shown in the figure. The rod is rotating about the vertical axis with a constant angular speed omega. At any instant r is the distance of the bead from the origin. Okay, the momentum conjugate to r means you have to find the PR here. And you know, normally momentum is what? Delta L over delta R dot. This is what you have to consider. Okay, that's what you have to do. So firstly, you have to get the Lagrangian, guys, and after that, you have to go ahead to simplify it further. So for Lagrangian, you need the kinetic energy and the potential energy both, as Lagrangian is equal to kinetic energy minus potential energy. So when you will consider the kinetic energy and the potential energy, see, the bead is moving as well as it's rotating about one axis, right? So this is not just the one motion, there are going to be two different motions, right? And in any such case, mostly we use the spherical polar coordinate system. So accordingly, you have to write the kinetic energy part, which is half m r dot square plus r square theta dot square plus r square sine square theta and phi dot square, right? And minus potential energy. So you know, in general the potential energy is mgh or mgz, but in this case, if you will look at the vertical component here, it will be r cos theta, because theta angle is made with the vertical axis. So that is going to be r cos 45 degrees, because theta is 45 degrees. And everywhere, even here, theta, 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 you can replace. So this will become 0 because theta is fixed, right? Because it's having a fixed or particular value. Now, after you are going to just consider all these values, you will have your Lagrangian. And then once you will have your Lagrangian, just consider delta L over delta R dot to get the momentum. And that's going to give you final answer as mr dot. You can just check it out and let me know if in case still there is anything not getting clear to you, or anywhere you are gonna find like, oh, there is this doubt. Done? Okay. We'll consider the next question now. And if anybody is gonna find it difficult to consider any of the steps, you can tell me, guys. While right now I'm not able to see anybody's comments, so let's go for the next question. But just these are the steps you have to take and will take you to final answer. Okay, next one is quite interesting. The Lagrangian of a system is given by L is equal to where M, L and G are constants. Which of the following is conserved? Options are phi dot sine square theta, phi dot sine theta, phi dot divided by sine theta, phi dot divided by sine square theta. Okay, now so for this one, it's even quite simple and easy. So you can start working on it and tell me if you know what are the steps you have to take care or what you have to consider to be correct. Otherwise, I'm gonna explain it to you guys that how to think about what you will need to do, what are the most suitable steps, and what will work best. So that's all like we will talk about. We are gonna consider everything. The Lagrangian of a system is given, right? And when you want to find the conserved quantity, mostly what you are going to do, you will see the cyclic coordinate or ignorable coordinate. And what is that coordinate? Whose like the coordinate is not there in the expression of Lagrangian, but its first order derivative is there. So you can see the phi is such coordinate here. The phi is not present, but the phi dot is present. So your momentum corresponding to the cyclic or ignorable coordinate will be conserved or constant of motion, which is delta L over delta phi dot. And in this case, you will get 2 phi dot and then sine square theta as it is and half ml square as it is. But they have already given you m and l are constants. So other than that, whatever you will have like the phi dot sine square theta, that's going to be your conserved quantity or constant of motion. Hence your option A is the correct answer. And that's your final answer too. Please tell me if in case there was anybody having any doubt. We will try to consider it. But if it is getting clear, we will be taking the next question then. Okay, next one I'm going to talk about is a particle moves in one dimension under a potential Vx is equal to alpha mod x with some non-zero total energy. Which one of the following best describes the particle trajectory in the phasor space? Options are just consider it to be symmetrical on both sides. I'll try to draw it once again. It should be again symmetric on both sides, the option D part. But still, with the options, you will be getting some idea about what I wanted to show you, what kind of shape it is. And then you can start working on this part and let me know, guys, what do you think is the right option. But if you will not be able to get it, I'll help you in that case. So I'm still gonna wait for everyone like to consider and to tell me what do you think is the right answer. Here are the options, guys. Okay, let me just quickly tell you. So basically, this is from the phases, space, trajectory, or dynamics, right? Uh, if I'm going to talk about this one, guys, the first thing you have to do is you will be plotting a v versus x graph, right? And then further, depending on how your v versus x graph is, so you will be able to consider it further. That's going to be like alpha mod x. So in that situation, it's going to be mod x, so towards positive side and towards negative side as well. Okay, it's going to be your v versus x graph you have drawn. Now, corresponding to that, you have to plot the momentum versus x graph. So you can see that the particle is bound, right? And other than that, you can also see that if I'm going to consider the potential keep on increasing as I increase the values of x. So which means the momentum should decrease. So when momentum will decrease, it will be something like that. And both sides, it will show you the same thing. But positive side will remain like connected to the positive x side, and the negative side will be remaining connected to the negative x side. So this is the type of graph which you will have, and that's giving you option A to be the correct one. Please tell me if there is any doubt. And if it is clear, guys, I'm going to give you the next question. So your option A is going to be the correct one. Okay, let me just take the next one. Okay, here it is, guys. generalized coordinate, and momentum. T is time and K is a constant. For the initial condition, Q is equal to 0 and P is equal to 0 at T is equal to 0. Qt is proportional to T to the power alpha. The value of alpha is that's what you have to find. And options are 1, 2, 3, and 4. Try it now and let me know whatever you think is the correct answer. If in case there will be any doubt you will have, we can consider it then. And if everything will be clear, that's great. So I'm gonna wait for everyone's reply for some time and then we will continue the discussion. It's like the type of question where you have to consider a few things. You have to think about it, what will be the best approach to solve it, how it can be done, and accordingly you will be just solving that part. So let me know if in case there was anything not getting clear to you or anywhere you're gonna have any doubt, then we can consider that part. Okay, let's go ahead and let's work on this part, guys. So actually in this case, what you have to do, in this case the Hamiltonian is given to you and you want to consider the Q dependency on T. So for this part you're simply going to consider delta H over, like the Q dot is equal to delta H over delta P and P dot is equal to delta H over delta Q, right? Give me a second. So you just have to use, oh, this should be negative sign here. You just have to use these equations, guys, and you will be able to get that. Okay, everyone, let's go ahead. Still, if anybody has not got the answer, I am gonna consider that part, okay? So it's going to be, let's consider Q dot. So when I'm gonna consider Q dot, I'm gonna get P over M. So Q dot is equal to what? P over M. And what about the Q dot? I can write it as dq over dt, so which will give me pt over m plus constant. But we know at t is equal to 0, q will be 0, so that will give us c0. So I can remove this part. P dot means dp over dt and negative delta h over delta q. What I'll get? kt there. So I'll have after integration kt squared over 2 plus d. So at t is equal to 0, p will be equal to 0, and that will give you d0, right? So in this case, p is going to be proportional to t square. So q will finally be proportional to t cube. So if you will look at the p dependency on t and q dependency, overall dependency you want to find on t, so that's how you will be able to consider it. Give me a second, guys. Okay, so that's how your answer will be 3 because the power 3. Okay, guys, let's go ahead. Done. I hope it's clear. So you just have to look at the dependencies every time. Like if there is P and it can be dependent on T. So you also have to look at how P is dependent on T. Then you will get to know overall Q dependency on T. So that gives you the answer 3 to be the correct one. Like for this question. Not for every, but yeah, that's the approach. That's the way you can solve such type of questions. Let's go over the next one now and let's take the next question. If in case anywhere anybody will have any doubt while I'm trying to explain all the steps, but you can tell me, but right now I can't see any comment. So I'm gonna go over the next question. I'll be writing the next question, guys. Okay. So our next question now we are gonna take is the one I'll be writing right now. It's let A, B, and C be functions of phasor space. variables which are coordinates and momenta of a mechanical system. If represents the Poisson bracket the value of A with the Poisson bracket of B and C minus A, B and C is given by, options are 0, B, C and A. A, C and B. C, A and B. Try it now and let me know as you will get it done. If in case you will have any doubt, I'll talk about it, guys, that how you need to take the steps or what you have to do in this case. So actually it's going to be let A, B and C be the functions of phase space variables, coordinates and momenta of a mechanical system. If this represents the Poisson bracket, the value of A, B and C minus A, B and C is given by. Okay, so here there is one identity you have to use. If you are already familiar with it, you can consider that part, but if you are not, I'll let you know how to do it or what steps you have to take then. Okay, guys, so we are having the Jacobi identity. Let me just quickly tell you about it, which is A with B and C. Like, I'll just shift them in a sequence. So now I'm gonna shift the B this side, C this side, like that. B, C, A, okay? Then once again, C, A, B. That's what you have to do. And then equal to 0. So now what you have to do next, you are simply going to consider, you want to find the value of ABC with AB Poisson bracket with C, right? You have to shift it. So whenever you shift these position, you get a negative sign. So you're going to get A, B, C minus A, B and C, right? And then that is going to be equal to negative sign of this. It will go on the other side. So when negative sign will be there, it will be C, A and B. So now you can check it out, like which option seems to be correct to you. And That's option D, which is the correct one. So this is how we can just arrange the equation. We can just try to make the form how we want it as per the question, right? And that works this way. This is how you're reaching to the final answer. If still anybody is having any doubt anywhere, you can surely let me know about it, guys. But if it is getting clear to everyone, that's great. I hope everything we have talked about till now and everything we are considering, that's making sense and everything is getting clear to everyone too. Okay, guys. If still anybody is having any question, query, or doubt, and something we have talked about is not getting clear to you, you can surely let me know then. But if everything is clear, that's great. Now we will be doing more discussion in our next session, which will be starting exactly after this one. And I'll be taking more questions and concepts there. So let me just see if I can give you one more question right now. Then we will be starting our next session in just few minutes. Okay, let's try to consider one more question. The Hamiltonian of a classical particle moving in one dimension is, the Hamiltonian is given to you as p square over 2m plus alpha q to the power 4, where alpha is a positive constant and p and q are momentum and position respectively. Given that its total energy, like here they have given you a condition, the total energy is E is less than equal to E naught. So you have to find the available volume of phase space depends on E naught as. Let me just write the options too. Give me a second. Okay, let's go ahead. Now I can see your comments, guys. Very good evening, Chandras. Very good evening, everyone. Hello, Vikas. That's great. Very good, Vikas. Very good, Kana. Uh, guys, I was not able to see your comments earlier, so I'm just now able to see it. Oh, kinetic energy Ekaf, we are gonna have for different coordinate systems. Depending on that, like you can memorize them, you can prepare them for cylindrical, for spherical, okay, and for all those different ones, and that will be helping you to write it for any such system. So I think that can be helpful. Even in my previous classes, I have talked about that what are the different energies, kinetic energies you can have for different systems. So that will be helpful for you. Jaspreet, not every day in the month, but yeah, most frequently. Thank you so much, Anirban. Thank you so much, and happy Teachers Day to everyone, guys. Because I believe that everybody is gonna share some knowledge in some form with others, and like you are gonna help somebody to learn something. So everybody is teaching, okay, on everyday basis. So happy Teachers Day to everyone. And guys, this is our last question for this session, and then we will have the discussion in our next class. Okay, so the question is, the available volume of phase space depends on E naught as what? So option A is E naught to the power 3 by 4. Option B is E naught. Option C says square root of E naught. And option D says it's independent of E naught. Okay, that's what you have to consider. Now guys, quickly I'm going to just gonna tell you the steps to work on it. But other than that, if anybody is gonna get the answer, select your answer or tell me in the comments what is the right answer according to you. Okay, So in any such case, we are gonna work on action angle variable, which is J. J is equal to integration P dq, and P in general is momentum, which is root 2 m e minus v. If somebody wants to solve the integration completely, they can do it with step by step with the whole process. But there is even a trick, like from the momentum part, just take the proportionality of J on E as e to the power half, and then you also have the potential term alpha q to the power 4. So you will write v is equal to alpha q to the power 4, but let at q is equal to b, v is equal to e, total energy, right? So in that case, we will get the b dependency on e as e by alpha to the power 1 by 4. So you're going to get it like e to the power 1 by 4 here. This is 1 over 2, which will give you e to the power 3 by 4. So this is how you are going to get the dependency of the volume of the phase space or action angle variable on E. So which is going to be your option A, which is the correct one. Okay, this is how you are going to do it, guys. So we are going to keep it this much today in this session, and I hope everything we have talked about today in the session is getting clear to everyone. But in case anywhere, if you will have any doubt, we can surely talk about it. And thank you so much everyone for joining this session. Let's keep it this much today in this session. As I have shown you the slides regarding the Unacademy Plus Iconic and the Lite subscription in the starting of the session, guys, you all can have a look at this. You can use and apply the code Anjali Live to get the discount in the total subscription amount and start your preparation under the guidance of top educators today. Thank you so much everyone for joining this session. Now we will be having our next session after this one, so everybody can join it. I'm just gonna start that one now. Okay, thank you so much everyone, and our new courses are soon gonna start. So if anybody wants to start their preparation under the guidance of top educators, then they can take your subscription and use and apply the code Anjali Live to get the discount in the total subscription amount. Thank you everyone. Bye. Take care. See you in the next session now.